Good morning students. Today we are going to study about the test for divisibility of number for 6, 8, 11 and 9. So let us see for 6. A number is divisible by 6 if a number is divisible by both 2 and 3. If we want to test that a number is divisible by 6 or not, so you have to see that whether it is divisible by 2 and 3. Then for 8, for 1, 2 and 3 and 4 digit number, we can just check the divisibility by actual division, means how we are dividing the numbers by division method like this one. But for number with 4 or more digit is divisible by 8 if the number formed by the last 3 digit is divisible by 8, as you have seen for divisibility for 4. For 4 we have seen the last 2 digit, but for 8 we have to see the last 3 digit or the number formed by unit, tens or hundreds place. We will see in our question when we'll solve in our exercise. Then 9. A number is divisible by 9 if the sum of digits of a number is divisible by 9. And this one 9 is similar to 3. In 3 also, if the sum of digit is divisible by 3, then we can say that the number is also divisible by 3. So you can remember that 6. 6 is a multiple of 2 and 3. It means if a number is divisible by both 2 and 3, then it is also divisible by 6. Then for 8, you can see, you can remember by 4. For 4 number, we will see last 2 digit, and for 8 we have to see last 3 digit. Then 9, 3 and 9 are 9 is a multiple of 3, so you can remember by 3 only that in 9 and 3 we have to use the same one. If the sum of digits of a number is divisible by 9 or 3, the number is also divisible by 9. And then 11, a number is divisible by 11 if the differences between the sum of digit at odd places from the right and the sum of digit at even places from the right of the number is either 0 or divisible by 11. We will see the example of this one in our exercise question only. Now question number 6 of our exercise 3.3. Check the divisibility of the following number by 6. We have to check whether this number is divisible by 6 or not. So what we have seen, if a number is divisible by 6, if a number is divisible by both 2 and 3. So let us see. We know that how to check whether a number is divisible by 2 or not. If its unit digit is an even number or 0, 2, 4, 6 or 8, then we can say that it is divisible by 2. So you can see here that its unit digit is 4, so it is divisible by, what is its unit digit or ones digit is 4, and it is divisible by 2, so the number is also divisible by 2. Now we have to check whether it is divisible by 3 or not. So first we will find sum of digit. Sum of digit means 7 plus 2 plus 3 plus 5 plus 4, which is equal to 21, and we know that 21 is divisible by 3. So you can see that the given number is divisible by both 2 and 3. Therefore 72,354 is divisible by 6. Without actually dividing by 6 directly, first we have to find that whether it is divisible by both 2 and 3. So we can say that it is divisible by 6. Second one, 40,083. First we will see that whether it is divisible by 2 or not. So we have to see its unit digit or the last place, ones place. Unit and ones place are same only. Ones or unit. So which is its unit place is 3, and we know that 3 is an odd number, so it is not divisible by 2. Now we will check for 3. So sum of digit 4 plus 0 plus 0 plus 8 plus 3. You have to add all the numbers, which is equal to 15, and 15 is divisible by 3. But you can see that it is divisible by 3 but not divisible by 2. For divisibility of 6, it should be divisible by both 2 and 3, but here one condition is not satisfied, so we can say that therefore 40,083 is not divisible by 6 because it is not divisible by 2. If one of the condition is not satisfied, then the number is not divisible by 6. Both conditions should be yes only. Third and fourth is same as question number first and second. First you have to see whether they are divisible by 2 and 3. If they are divisible by both 2 and 3, then only you can say that it is divisible by 6. Now see the fifth one. 3,62,910. Its unit digit is 0, so it is divisible by 2. Now sum of digit 3 plus 6 plus 2 plus 9 plus 1 plus 0. So 6 plus 3, 9, 9 plus 2, 11, 11 plus 1, 12, 12 plus 9, 21. And we know that 21 is divisible by 3. So you can see that 3,62,910 is divisible by both 2 and 3. Therefore, it is divisible by 6 also. Now question number 7. Check the divisibility of the following numbers by 8. And what we have seen for 8? We have to see the last 3 digit. So last 3 digit 14,548. So the number found by 100, tens and unit place. So which is the unit place here? 8. At tens 4 is there, and at hundreds 5. Or the number found by the last 3 digit. Which is the last 3 digit? 8, 4 and 5. So which is equal to 548. Now we have to see that is 548 is divisible by 8 or not. So divide 548 by 8. So you can see that 8 6 are 48. Now minus this, it will come 68. 8 8s are 64. So remainder is 4. It means it is not exactly divisible. So if 548 is not divisible by 8, then you can say that 14,548 is also not divisible by 8. Fourteen thousand 548 is also not divisible by 8, as 548 is not divisible. Second one, 64,37,536. So again we'll see the number found by the last 3 digit. Which is the last 3 digit here? 6, 3 and 5. Or we can say that 536. Now we'll check whether 536 is divisible by 8 or not. So 536. 8 6 are 48. Then here 56 and 8 7 are 56. You can see that here remainder is 0. It means 536 is exactly divisible by 8. So 536, which is divisible by 8, so 64,37,536 is also divisible by 8. Third one, 9,408, which is the number found by the last 3 digit is 408. And 408 is also divisible by 8. So 9,408 is divisible by 8. Only you have to see that the last 3 digit, the number found by last 3 digit is divisible by 8 or not. If it is divisible by 8, the number is also divisible. Same fourth and fifth one is left for you as a homework. Only you have to see the last 3 digit and check that whether they are divisible or not. Now question number 8. Check the divisibility of the following numbers by 11. Now for 11, what we have seen? We have to find a number is divisible by 11 if the difference between the sum of digit at odd places and sum of digit at even places is either 0 or divisible by 11. So sum of digit at odd places. Odd places means the place it 1, 3 and 5, and even places means 2, 4 or 6. So you can see 6, 1, 8, 0, 9. The number, the digit at odd places. Odd places means what is the place of this one? 1, 2, 3, 4, 5. These are the places of the given number. Odd places means 1, 3 and 5. So these 3 are odd. And 2, 4 means 1 and 0. These 2 numbers are at even places. So you can see that the sum of digited odd places. Which are the digited odd places? At 1, 9. At 3, 8. And at 5, 6. Now add this 9 plus 8 plus 6, which is equal to 23. Sum of digited even places. Which are the digit at even places are given here? Even places means at 2 and 4. So at 2 means 0 and at 4 means even places 1 is there. Here you have to see these numbers at odd and even places. So 0 plus 1 and you have to find the sum 1. Now after adding the sum of digits at odd and even places, you have to find the difference. Difference means minus. So find 3 minus 1 is equal to 22, and we can see that 22 is divisible by 11. Therefore 61,809 is also divisible by 11. Let us see second question, 308. Again we will see the sum of digits at odd places. 308, which is the digit at odd places, means 1, 2, 3. These are the places of the given number. Odd places means that 8 1 8 is there and 8 3 3. So 8 plus 3, which is equal to 11. And here only one digit at even place, which is equal to 0. So sum of digit at even places is 0. Now find the difference. Difference means we have to find the minus subtraction. We have to subtract 11 minus 0. So 11 minus 0 is 11, and we have to check whether the difference is divisible by 11 or not. So 11 is divisible by 11, therefore 308 is also divisible by 11. Third one, 1331. Again we'll find the sum of digits at odd places. So 1 3 3 1. Odd places means here 1 2 3 4. At odd places 1 is there and 3 is there. Now add 1 plus 3, which is equal to 4. Sum of digits at even places. Even places means 3 and 1. So 3 plus 1 4. Now find the difference. Difference means minus. We have to subtract this both number from each other. So 4 minus 4 0. And we have seen that the condition is given if difference is if the difference between the sum of digits at odd and even places is either 0 or a number which is divisible by 11, then we can say that the number is divisible. So here what is the difference came here? 0, and 0 is divisible by 11. Therefore 1331 is divisible by 11. We know that if we divide any number by 0, the answer is 0 itself. So if we divide 0 by 11, the answer will be 0. So we can say that 1331 is divisible by 11. Fourth one, 5,86,949. Again we'll find the sum of digits at odd places. So 5 8 6 9 4 9 means 1 2 3 4 5 6. These are the places of the given number. So odd places means 1 3 5. So which are the number at odd places? 8 9 and 9. Now find the sum. So 9 plus 9 plus 8, which is equal to 19. Sum of digits at even places. Even places means the left number 4 6 and 5. So 4 plus 6 plus 5. 4 plus 6 plus 5 is equal to 15. Now find the difference, means 19 minus 15, which is equal to 4. And we know that 4 is not divisible by 11. So 5,86,949 is also not divisible by 11. The last one, this given number. Here you can see many of the numbers, digits are given in the given number. So first we have to see the sum of, you will see its digits at odd and even places. So number is given as 8050314052. So 1 2 3 4 5 6 7 8 9 10. These are the places. First is at odd place, means 1 3 5 7 9. At 1, which number is given? 2. So write here 2. At 3 0. At 5 1. So 0 and 1. At 7 0, and at 9 also 0. So first add the digit at odd places. So 2 0 1 0 0, which is equal to 3. Now the left numbers are at even places, means which are the number at even places? 5 4 3 5 and 8, and find the sum, which is equal to 25. Now find the difference between them. Here 25 is greater than 3, so we'll minus 3 from 25. So 25 minus 3 is equal to 22. and 22 is divisible by 11. Therefore, the given number is also divisible by 11. Now question number 9. Check the divisibility of following numbers by 9. And we have seen that for 9, we have to find the sum of the given number. If the sum of digit is divisible by 9, then we can say that the number is also divisible. So sum of digit means 1 plus 0 plus 9 plus 8, which is equal to 9 plus 8, 17, 17 plus 1, 18. And 18 is divisible by 9. How many times? 2 times. So 1098 is also divisible by 9. Only you have to find the sum of the given digits in the number. Second one, 87,100, 8,71,245. So first we'll find sum. So 8 plus 7 plus 1 plus 2 plus 4 plus 5. So if we add, we'll get 27. And 27 is divisible by 9. How many times? 3 times. So we can say that if 27 is divisible by 9, so the number 8,71,245 is also divisible by 9. Third one, 40,06,839. 4,06,839. Now find the sum of the digit. 4 plus 0 plus 6 plus 8 plus 3 plus 9, which is equal to 30. If we add, we'll get 30 here sum. And we know that 30 is not divisible by 9. You can see if we divide 30 by 9, 9 3s are 27. Here remainder is left 3. It means it is not completely divisible by 9. So if 30 is not divisible by 9, therefore the given number is also not divisible by 9. Fourth and fifth one is left for you as a homework. Now the last question of our exercise, question number 10. Write a digit in blank space of each of the following number so that the number formed is divisible by 11. In the given vacant place, you have to find a number so that the given number is divisible by 11. So 92-389. Let us take this vacant place, the fill in the blanks as A. So we can write it as 92A389. And we have to see in that we have to find a number so that this number should be divisible by 11. We know that what is the condition of 11? If the sum of digit at odd places and sum of digit at even places, if the difference is equal to 0 or 11, the given number is divisible. It is already divisible, only we have to find the number. So first we'll see the sum of digit at odd places. So write 9, 2, A, 3, 8, 9. So 1, 2, 3, 4, 5, 6. These are the numbers at different odd and even places. So which are the numbers at odd places? 1, 3 and 5, 9, 3 and 2. Now find the sum. 9 plus 3 plus 2, which is equal to 14. Now we'll see the sum of digit at even places. So which are the at even places? Here 1, 2, 3, 4, 5, 6. At even places means 6, 4 and 2. So with the numbers are at even places are 8, A and 9. Now add all this number. So 8 plus A plus 9. So 9 plus 8, 17 plus A. Here you can see that A is a symbol to which we can add, and we have to find the value of this one. Now the next step is to find the difference between the sum of digit at even and odd places. So the sum of digit at even places is greater than sum of digit at odd places. So first we'll write this one 17 plus A. So 17 plus A minus 14. Now find the difference 17 minus 14. So 17 minus 14 is 3 and 3 plus A. Now we have to see that in place of A, which number should be added in 3 so that the given number is divisible by 11. So the difference should be 0 or multiple of 11. If we find the difference between 17 plus A minus 14, the answer should be equal to 0 or 11 so that the number is divisible by 11. So taking a closest multiple of 11, which is nearer to 3. Now we have to see that which number should be added in 3 so that the answer should be equal to 0 or 11. Here you can see if we take in place of a minus 3, so 3 minus 3 is equal to 0 and the given number is divisible by 11, but minus 3 we cannot use here, so we have to use only the positive number. So now 3 plus a is equal to 11, or you can see that 11 minus 3, here 3 is given in positive in this side, so if we take to right side it will change into minus, so 11 minus 3 is equal to 8, or you can see that if we add 8 to 3 in place of a, if we'll take 8, so 8 plus 3 11, and 11 is divisible by 11, so the number should be equal to 8 only. So therefore the required digit is 8, or 9 to 8, 3 8 9. Only we have to see that we have to, in place of a we have to take a number so that our answer should come equal to 0 or 11. Here 0 is not possible, so we have to make 11 here, so that if we add 8 only in 3, then only the answer will come as 11. Therefore the required digit is 92, 9,28,389. Second one, 8-9484. Let a be placed here. Let us take in place of the vacant place a. Again the sum of digit odd places. So which are the odd places here? 8a 9 4 8 4, so 1 2 3 4 5 6. Odd places is 1 3 and 5, means 4 plus 4 plus a, so 4 plus 4 plus a, which is equal to 8 plus a. Sum of digit at even places. At even places, which are the given digits? 8 9 and 8, so 8 plus 9 plus 8, which is equal to 25. Now we'll find the difference. Difference means 25 minus sum of digit odd places, 8 plus a. Now we'll open the bracket. So 25 minus 8, and here if we multiply the sign, so minus plus minus, which is equal to minus a, will come here. So 25 minus 8, 17, 17 minus a. Now we have to find a value of a such that which we subtract from 17, so that the answer should come equal to 0 or 11. So if place of a, if we take 17, so 17 minus 17, 0, but we do not have to take a number as negative number here, so we have to take a number so that it should be equal to 11. So which number should be subtracted from a so that the answer should be equal to 11? Or you can see if we subtract 6, in place of a if we take 6, the answer will come as 11. So 17 minus a, the difference should be equal to 0 or multiple of 11, then the number is divisible by 11. Now we can take a multiple of 11. Let us take 11. Here we have to find 17 minus a should be equal to 11. So a, again here a is given in negative, so if we take to right hand side it will change into positive, and here 11 is given as positive, and if we take to this side it will change into negative. So 17 minus 11 is equal to 6, or you can see here only directly from here which number should we take in place of a, so that if we subtract from 11 the answer should be equal to 11. So if we take 17 minus 6, it will come as 11. It means the value of a is equal to 6, and if we write in place of the given place 6 here, the answer is divisible by 11. I hope you have understood these questions. So on the next day we will see the new topic.